Tiga. Assalamualaikum and hi everyone, especially to Dr. Amalina.
So today we are going to talk about technique of differentiation for MAT183, and we are from EC11101 1B2.
I'm Eliafana binti Tun Sri Akmal, 2025 693-719.
My name is Nur Maira binti Jujani, 2025883206.
And my name is Jamia Kasimashwa binti Rahal Hafizan, 2025890992. So let's get into it. Woo!
What is differentiation?
So differentiation in calculus is the process of finding function derivative which measure its instantaneous rate of change and the slope of tangent line at any given point. So calculus differentiation technique involve technique of differentiation which is derivative of constant, linear and power function, derivative of sum and difference, product rule and quotient rule,
Derivative of trigonometry, exponential and logarithmic function.
The chain rule,
equation of tangent to a curve,
Second derivative,
implicit differentiations.
and last but not least, linear approximation and differential. So let's go and solve our own question.
sin, it will be cos, so write it back 3x square plus 1 over power of 5, and using x square plus 1, so it will be 6x, and multiply it with 5 with the 3x square plus 1 of the power of 5, so the 5 will be at the front, and just write 3x square plus 1 back. So the power will be 4. The power will be 4, and then we write it back, but this 6x multiple 5, 3x square plus 1 power of 4, we put it in front of the cos, and it will be 30x multiple 3x square plus 1 power of 4, and just write cos multiple 3x square plus 1 power to the power of 5, and
2, which is find dy over dx for function exponent with the power of 4x sine 2x over x2 plus 3. So we are going to use two rules, which is product rules and quotient rules. Okay, first product rule, dy over dx equal to u v prime plus v u prime. Okay, and then the second quotient rule, which is dy over dx equal to where is the quotient rule? Wait. Okay, v u prime minus u v prime over v square. Okay. And then what we are going to do, which is y equal to exponent x sine 2x over x square plus 3. Okay, here is the question. So we are going to differentiate this one first, this one, the above this. Okay, so differentiate using product rule, because this is not divided by something, so product rule. So for u equal to e for x, e with the power of 4x, and for the u prime equal to 4 e for x. And then for the next step, which is v equal to sine 2x, and for the v prime equal to sine convert to the differentiate sign is of cos, so 2 cos 2x. And we are going to insert all these u prime v prime into the product rule, which is dy over dx equal to e for x multiply 2 cos 2x, okay, plus sine 2x multiply 4 e for x, okay. And then we are going to organize this to make it look better, and I think it's follow the some equation, put sign on the front and something. Okay, so this we are going to multiply with exponent, so 2e for x multiply cos 2x plus this we are going to multiply to the front, no I mean yeah for it's for x sine 2x. So we put this form for exponent with the power of 4x to the front, so it mean so it look even better. So we finish with the first step for this part, which is using the second step quotient rule. These equations dy over dx equal to v u prime minus u v prime over v squared. So from product rule, we find that, okay, like I said, I just differentiate the top one, the numerator one. So that means these equations is the u prime, okay, because this is u and this is v, okay. So right now, to do the quotient rule, the only thing we need right now is v prime. So I prefer just to list down the things. So I will write it again. Dy over dx equal to v u prime minus u v prime over v squared. And remember to put the over v squared. So I will list it down, which is u equal to exponent for x sine 2x. Okay, for the u prime, I will just copy and paste. Okay, I will put it over here. Okay. And for the v equal to x squared plus 3. And for the v prime, just differentiate. So it will be 2x, only 2x. Okay. And we are going to put all this stuff into the equations, which is going to be like this: dy over dx equal to, first put the v, x2 plus 3 multiply, or I prefer to use bracket, so okay, I will use bracket. Okay, I'm just going to copy paste. Okay, sorry. Okay, copy and paste like Madam said. Okay, so to avoid from just write wrong somewhere. Okay, and then plus, okay, plus, and then minus u is u. Okay, I forgot to put a big bracket, so I won't get confused. So let's move on, which is u exponent for x sine 2x, and another bracket of 2x, just 2x, okay? And a big bracket so I won't get confused. And don't forget to over v squared, which is x2 plus 3. So for the final result, like I said, I will organize it. So sorry. So dy over dx equal to, I'm going to put this 4 exponent for x to the front, but I just 2e for x, okay, and the bracket, and x2 plus 3 bracket again cos 2x, and plus 2 sine 2x. And why is here 2? Because I already put it here, so it's going to multiply, so there's nothing. And then proceed, minus 2x exponent 4x sine 2x, okay. And then of course I prefer to put it in the bracket, and this one is a big bracket, okay. And then don't forget over v square, which is this v square, okay. I forgot to put the square at the top, so sorry, my bad. So here is x2 plus 3 square. And this is the final answer for the question number 2. X squared exponent with power of y plus 10y cubed equal to 5x minus y ln x. And we have to find the dy dx by using the implicit differentiations. So x squared ey plus 10y cubed equal to 5x minus y ln x. Okay. So this is the equation. I will solve this one first using product rule. So dy over dx equal to u v prime plus v u prime. Okay. This is the product rule. So I will list it down, which is u equal to x squared, and for the u prime is 2x, and for the v is e with power of y, and for the v prime is ey multiplied with dy over dx, because it with the power of y, not with the power of x. So, and insert the u prime v prime into the product rule. So it's going to be like this. It's 2 multiplied with e with power of y by dy over dx plus ey multiplied with 2x. Okay, this is using the product rule, and plus because the equation said e plus, and 10 we need to convert the 10 to sec, which is going to be sec 2 y3, and don't forget to multiply with the 3y square dy over dx. And now we are going to differentiate the last one. This is going to be like 5 minus y multiply with the 1 over x, which is f from here, plus ln x multiply with dy over dx, close bracket.
Okay, and so for the next step, we need to bring this one to the front. So it will become like this. Plus exponent y multiplied with 2x plus 3y squared sec 2 y3 dy over dx equals to 5 negative y 1 over x negative ln x dy over dx. So when it become like this, bring dy over dx to the front. So it will become dy over dx x squared exponent y plus, we need to add on another dy dx to the front of 3y squared. So it will become like this. So dy over dx 3y squared sec 2 y3 and bring ln x dy over dx to the other side. So it become positive ln x dy over dx equals to 5 negative y 1 over x minus, let me just size it down a bit so that I can write down. And you must be wonder, where did exponent y multiply to x go to? So we put it here, 2x. Okay, so this is our next step. And next step, we factorize the dy dx from another number. So we keep it away from another number, and it will become like this: x2 e exponent y plus 3y2 sec 2 y3 plus ln x equals to 5 minus y 1 over x minus exponent y multiplied with 2x. So for the next step, I will let Umay solve it.
dy over dx and bring all of this to the other side, and it will be dy over dx equal 5 minus y multiple 1 over x minus exponent y power y multiple 2x over this one. So x squared multiple exponent y plus 3y squared sec squared multiple y power of 3 plus ln x. So the next step is dy over dx equal to we can simplify it. So it will be 5 minus y over x. And then 5 minus y over 0 minus, so this if we multiply with exponent y, it will be minus 2 x exponent power of y over, so you multiply it and it will be x square exponent power of y plus just, and then this part you just write it back, and 3y square multiple y power of 3 plus ln x. That's all.
Okay, so right now we are going to solve question number 4. We need to use linear approximation to estimate the value of this equation. So first of all, we need to know the value of x, x naught, and delta x. As for the x, we can find it from the equation that was given. So from this one, we can know that x is equal to 11.96. And as for the x naught, to find it, we need to see the closest number to x. So the closest number to 11.96 is 12. So that means our x naught equals to 12. And as for delta x, we need to use formula x minus x naught. So 11.96 minus 12. So we will get negative 0.04. So our delta x is negative 0.04. So next step, we need to find f delta f x naught. So from this equation, x naught plus 16. So replace the x with x naught. So f x naught equals to square root x naught square plus 16. And as we know, x naught equals to 12. So replace the x naught with 12. So f12 equals to 12 square plus 16. And we will get 4 root 10. And next, we need to find f prime x. So f prime x equals to square root x square plus 16. So change the root to a power. So it will become x square plus 16 half. And bring the power to the front. And it will become half x square plus 16. And the power will become negative half. And we need to multiply it with 2x. Where and how did we get 2x? Let me show you. So we just need to use it from x square plus 16. Bring the square to the front, it will become 2x. And since 16 doesn't have x, it will automatically disappear. So that's how we get 2x. And the next step, multiply 2x with the front, we will get x square plus 16 minus half. It will become x square root x2 plus 16. And the last step, we need to use fx naught plus delta x equals to fx naught fx delta x. And replace it with the value that we get, 4 root 10 plus x x2 plus 16, multiply it with negative 0.04, and replace the x with the value that we got, which is 11.96. So 4 root 10 plus 11.96 square plus 16, multiply with negative 0.04, and of course use your calculator to get the value. So 4 10 plus 11.96 0.96 2 plus 16 negative 0.04, and we will get 12.611. So this will be our final answer. So that's all for me. Okay, so in conclusion, Differentiation in calculus involves various techniques depending on the form of this function. Basic differentiation rules are used for simple function, while more complex rules require the application of the product rule, quotient rule, and chain rule. Implicit differentiation is applied when a function is not expressed explicitly in terms of one variable, and linear approximation is useful for estimating function value near a known point. Mastery of this technique allows accurate calculation of rates of change and effective problem solved in calculus. Thank you.